questions carefully in this unit, because a proving question is quite a bit different than a solving question. When you have a proof question, you have to draw the line, and you're never allowed to move things from one side of the line to the other. A solving question isn't always true, but there's only maybe a couple of values of x that make it work. There you're allowed to move from one side of the equation, just like you used to solve for x in the past. So it's a solving question, but what makes the solving question difficult is that I have a sine x and a cosecant x. So a strategy, just like in proofs, is if you're dealing only with one trig function, you should be able to solve it easier. So I can change the cosecant x to 1 over sine x. Okay? And this is like 2 over 1. So technically this is 2 sine x equals 3 plus 2 over sine x.
Huskies can have all the grade 9 and 10 classes down with their teachers, please, in the gym. That's all 9 and 10 down to the gym for a grade level meeting. Thanks.
Very common mistake, I'll just put it off to the side. Think about that for yourself. If you had 2 cosecant x and you wanted to change the cosecant x to sine x, it's 1 over sine x. Be careful that you do not move that 2 down with it. That's why when I did the work here, I did the cosecant on its own in brackets. And then that 2 out in front is like a 2 over 1. It stays in the numerator because of your rules for multiplying fractions. But sometimes we want to do things fast, and the cosecant's like, oh yeah, that's just a sign on the bottom, and the sign on the bottom is like, hey 2, why don't you come with me? And then you accidentally put that 2 on the bottom as well. So we just have to be careful with that. Our little thing off to the side. That has to be done separately. The cosecant is 1 over sine x. That leaves us with 2 over sine x. Now, this is a grade 11 rational equations question, where you have things in fractions. Do you like solving equations with fractions? Usually the answer is no. What is a really good way of getting rid of fractions in equations? Multiply. Could you multiply everything here by sine x? Yes. So I could multiply this by sine x, this by sine x, and this by sine x. Because if I multiply one side by sine x, I need to multiply the entire other side by sine x. And what's going to happen is here, they go away, leaving me with 2 sine squared x equals 3 sine x plus 2. So this question started as a solving question that had sine and cosecant, and we used an identity to get all the signs. Then it turned into a rational equations question from grade 11, where you learned that, hey, usually solving rational equations, I'd like to get rid of the fractions, so I multiply. And now it's turned into a quadratics question, because we have a sine squared. How do you solve quadratic questions? You make one side equal to 0, and then either factor or use a quadratic formula. Does this factor nice? Well, if it would have to be 2 sine x and sine x. My last number is a 2. Either 1 and 2 or 2 and 1. I need my outside and inside to make 3. So I'm thinking if I make my outside 2, that'll make 4 on the outside and 1 on the inside, could make 3. I need a -3, so I read a -4 and a +1. Multiply it out and double check, and sure enough, it works. And now it's chapter 6 question. Because here you're going to get sine x equals -1/2. And here you're going to get sine x equals 2. -1/2 is on your pi plate. That's your pi/6 family. Negative in quadrants 3 and quadrants 4. 2 is not on your pi plate, but this is still non-calculator. This is not possible. Anytime you have a sine value or a cos value bigger than 1, think about drawing a triangle with SOHCAHTOA. That would mean your opposite side is larger than your hypotenuse. And that is not possible. And at this point, notice I solved between 0 and 2 pi. And now is the moment of truth. I'm going to scroll up. I'm hoping this question's not in degrees. I'm hoping it's not a different interval, but I'll check once I find out. Okay? Oh my goodness, there's it. This is so happy. Look at that. I'm super happy right now. It was in radians and it was 0 to 2 pi. I'm done. Sometimes you read that part again like, oh, you have to do more work. But in this case, I'm super happy because I am done. Okay. So, the strategy that comes up on this one is, can you change things so that you only have one trig function? If you can, that can make your solving easier. So let's look at part B. Sine x equals cos x. There are some people who just do this one by inspection. Think about your pi plate. Sine is your y coordinate, cos is your x coordinate. Are your x coordinates and y coordinates ever exactly the same?
Yes.
What family?
Pi over 4.
Pi over 4. And which quadrants? All of them?
One.
One? Just one? So x equals pi over 4?
Oh, and 3.
And 3, right? Because in 3, they're both negative. But not in 2, because 1 is positive and 1 is negative. And not in 4, because 1 is positive and 1 is negative. So there are some people who just solve this one by inspection. That's perfectly fine. Okay? Or, there is a clever way that you can change this to be only one trig function. So right now it's two trig functions. It has sine x and it has cos x. Any strategies that you think you could do on this question that make this only one trig function?
Change it to 10.
We could change it to 10. How would you change it to 10? You would need,
Sine by cos.
we would first divide both sides by cos. You see that that would change that to sine over cos equals 1. And then sine over cos is tan. And now I have only one trig function. What family is tan x equal to 1?
Pi over 4.
Pi over 4. And in which quadrants is tan positive?
1 and 3.
1 and 3. Oh my goodness, same answers. So this one, there's sort of two different ways. The nice thing about the second way is you feel like that was algebraic and you could say for certain. The first way is sort of like, I just kind of know. Sometimes doesn't feel like enough work in math class, right? Okay. So, circle question number 10.